Okay, it's the introduction to data structures. So what definition of it? So data structure is organized collection of data is called data structure. So data structure is a logical arrangement of data elements combined with set of operations we need to access to that elements. So whenever we arrange some elements in a particular order and we want to perform some operation on that elements, we call that arrangement of element with the particular operation as data structures. So we can say data structure is a combination of organized data as well as the operation that is being performed on that data. Right. So today we will come to know what are the various arrangements that we can arrange data in and what are the various operations that we can perform on all the arranged data. So here is the classification of data structures. Data structures can be classified as linear data structures or non-linear data structures. Linear we have further partition as static and non and dynamic. So in static we have array, in dynamic we have stack, queue and linked list, and in case of non-linear we have tree and graph. So what is the meaning of linear? Linear means that data is arranged in a particular order, first element, second element, third, fourth, fifth, and non-linear means there's not a particular order for the arrangement of data. Static means in which there is no change of memory during compilation, and dynamic means that there is change of memory during compilation. So this is a brief introduction about the classification. Let's start further. Okay, classification of data structure is primitive, non-primitive, linear, non-linear. So what is primitive? Data structure that are not composed of other data structures, for example integer, float, boolean, character. So integer is a number that is created by itself, so there's no need to create integer with the help of another number. Similarly float, boolean and character. Whereas non-primitive means data structure that are constructed from other data structures, that with the help of some other data structure we have to create new data structures. We call it as non-primitive. For example, array. We create an array of size 10. It means I can call that array if I have to arrange 10 integers in that particular order. We call it as array. It means with the help of integers, I can create array. With the help of characters, I can create string, as well as with help of some data, I can create the record. Similarly, linear data structures, data structure in which elements are arranged and processed in linear order, that is in a sequence. For example, array, stack, and queue, etc. Non-linear data structure in which elements are not arranged in a process and processed in a linear order, but in which the elements are not arranged in a particular order, but they are processed in a linear form, first, second, third, fourth, in such manner, but they are not arranged in a linear order. That are the non-linear data structures. So we move further. Types of data structures, linear and non-linear. Again, the linear data structure traverse data elements sequentially, first, second, third, fourth, in which only one data element can be directly to be reached, whereas non-linear data in every data item is attached to several other data items in a way that are specific for reflecting the relationship. For example, in a tree, one root have multiple branches, so to which branch we have to move next, so that is known as the non-linear. So no, there is no such pattern over there. So now we talk about the what data structures come under the category of linear and what data structures come under the category of non-linear. So linear data structure traverse the element sequentially, in which only one data element can be directly to be reached. Traverse means that we are accessing the element, that we can traverse only one element at one time. So in which we have array, linked list, and stack. And linear data structure can be categorized into categories, that is static and dynamic. So what is static? Static data structure whose size and memory location is fixed during compilation time. So we cannot change the size of the data structure, as well as we cannot increase or decrease the memory of that particular data structures. We call it as static. Whereas in dynamic data structures, data structure whose size and memory we can either expand or we can shrink as required during the execution of the program or execution of the items. So that is the dynamic. So we can say we can increase or decrease the size of stack. We can increase or decrease size of queue or linked list. So these are the dynamic. So this is static and dynamic. Let's start with the linear data structures. What are the various data structures that come under the category of linear? So we have arrays, stack, queue, and linked list. These are the data structures that come under the category of linear data structures. So we start one by one. What is array, what is stack, what is queue, and what is a linked list, and what are the various operations that are being performed on all these data structures. Let's start with the first one, that is array. An array is a collection of homogeneous types of data elements at consecutive locations. Homogeneous means all the elements are of same type. That if I'm going to access an array, either that array be having all the integer elements, either that array be having all the floating elements, or either that array might be having all character elements. So it means whatever that elements are, they all are of same type. So when I arrange all the elements of same type in a particular order, I call that as an array. So an array is a collection of homogeneous uh, type of data elements at consecutive location. So what are the various operation that I can perform? So I can perform the various operation like traversing, searching, insertion, deletion, sorting, and merging. So if I'm having, let's say, an array of 5 elements, all 5 elements are integers. So I can access all the 5 elements at least once. So accessing the element at least once, I can call it as traversing. So traversing is a process of accessing each and every element in an array at least once. So we call it as traversing. Searching is that I have to find some particular element in a set of elements in array. So searching is a process of finding an element in an array. If the element found, the result is true. If I am unable to find the element from the array, the result will be false. To add a new element in that array, we call it as insertion. Insertion is a process of adding an element in the existing array and increase the size of array by 1. So if the size of array is 5, I add one more new element in it, the size becomes 6. So it means the adding a new element to an array will increase the size of an array. So insertion is the process to add an element in an existing array and increase the size of an array by 1. Deletion means the removing the element from an array if that element exists in the array. If the element is already in the array, I want to remove that element from array, I call it as deletion. Deletion is a process to remove an element from an array and reducing the size of an array by 1. If there are 5 elements, I delete one element from that array, it becomes 4. It means the size is reduced from 5 to 4. Sorting means that I have to arrange the element in some particular order, as ascending order or descending order. So sorting is a process of arranging the elements of an array in ascending or descending order. And merging means that I am combining two arrays together. If I am having array A and array B, all the elements of array B, either you can add in the before the first element of array A, or you can add after the last element of array A. So merging is a process of combining two arrays and make it as a new array. Let's say A is one array having 5 elements, B is another array having 6 elements. I combined all of them together. I combined the array B to array A. Then the size of array will become A will become size of array A, that is 5, plus size of array B is 6, 5 plus is equal to 11. After merging, the size of array A will become 11. So this is what how we can represent. I'm having array A 23, 55, 44, 99, 44, 11, 144, all are of type integer, and 0, 1, 2, 3, 4, 5, 6. So I'm having array of size 6. Similarly, I'm having array B. Array B is of element 4 elements, 0, 1, 2, 3, 23, 55, 44, 99. So if I want to add one new element in array B, then it becomes 0, 1, 2, 3, 4. You can add some new element after 99. Or you want to remove some element from array B, it becomes 0, 1, 2, and I will having 23, 55, 44 because 99 is being removed by me. If I want to sort the array A, so you can say the elements of array A are 23, 55, 44, 99, 44, 11, 144. So they are not in any particular order. Either they are in ascending order nor they are in descending order. So if I want to arrange the element in particular order, so it's, let's say, in ascending order, first element is the least element and last element is the highest element. 11, 23, 44, 44, 55, 99, 144. So, and merging means that I am adding the element of array B after the last element of array A. Last element of array is 144. After 144, you can see all the elements are of array B. So these all are the how we can say that this is the merging the elements of an array. So a stack is a list of elements in which an element may be inserted or deleted at one end, which is known as top of the stack. The stack is also known as last in, first out. If I pick some element, let's say a book, the first book I will pick, I put on the let's on the table. Then I pick the second book, I put that the second book over the first book. Then third book over the second book, fourth book over the third book, and so forth, so on. If I pick the last book, that is sixth book, that sixth book will be on the top of the stack. So it means we always mark a particular variable that is top. Top will tell us which location we are at now, and which element is at top. And if I have to delete that element from that stack, the element that is on the top will be deleted first. That's why we call it as last in, first out. The element that is being entered last to the stack is the first element that have to be removed from the stack first. So operation performed on stack are push and pop. If I want to add something to a stack, I call it as push. If I want to remove something from stack, I will call as pop. So push is to add an element in the stack and increase size of element by 1. Pop means to remove an element from stack and reduce the size of the stack by 1, not array. It is stack over here, stack by 1. So you can see over here, at last I was having a of 0 as 23, a of 1 as 55, a of 2 as 44, a of 3 as 99, a of 4 as 44, and a of 5 as 11. That is top. The first element I picked up is 23, that is the bottom, and the last element I picked is 11, that is on the top. So if I want to remove something, or if I want to add something, if I want to add some new element to the stack, that element will be added at the top of the stack. It means now 11 will not be the top one because we have added one more element to the stack, that is 144. Now 144 will become the top of stack. Earlier I was having 6 element. After adding 144 to the stack, it become 7 elements. If I want to remove some element from stack, that is pop. On the top, I am having what? I am having 11. Sorry, 144. I was having 144, so 144 will be removed because it's on the top. So if I remove 140 from the top location, that is pop for 144. Now, if 144 is removed, then at currently on top right is element 11. So 11 will become at the top location. Again, if I want to remove something, pop something, then 11 will pop. Then 44, then 99. I cannot pop any element that is not on the top. I cannot pop 11, I cannot pop 44, 99, 44, 55, 30, 23. I can only pop that is element on top, that is 144 in this case. Similarly, in this case, on top is 11, I can pop element 11. Fine, that's why we call it as last in, first out. The element that is being last entered to the pop is the first element that has to be removed from the stack. Next is queue. Okay, what queue is? Queue is a linear list of elements in which insertion can be done at one end, which is known as a rear end. It means that if new element has to be added in the queue, it will be added at the last of the queue. Rear means last. And the deletion can be done, which is known as front end. The element that is in the front of the queue will be the first to be deleted. That's why we call queue as a first in, first out. If let's say you went to the railway station and you want to borrow a ticket, if the queue is empty, no one is there, you stand at the first location of the counter. Let's say you reached over there by 5 a.m. The person who reached over there after 5 a.m., it will be second one to you. The person who come later to second one, that become third person, then fourth and fifth. And because you are the first person that visited over there at 5 a.m. when counter opens, you will be the first person who will get the ticket. So it means that you are standing at the first location, front location. You will get the ticket first. You will be out of the queue first. The person who visited late in to collect the ticket, he will be at the end of the queue, and he will be the person who will get the ticket at last of the queue. That way we call it as first in, the first out. The person who visit first will get the ticket first, and the person who will visit last will get the ticket at last. So what are various operations that can perform in queue are insertion and deletion. Either we can insert an element in a queue or we can delete an element in the queue. If you want to insert, that element will be inserted at the rear end, last end of the queue. And we want to delete something from the queue, that deletion will be done from the front side of the queue. Add a new element in the queue at last end, or you can say rear end. Increase size of queue by 1. Deletion means removing an element from queue at the front end and reduce size of queue by 1. So let's say this is an example. I'm having a queue A0, A1, A2, A3, A4, A5, A6. So 23 is the first element, 55 second element, 44 third, 99 fourth, 44 fifth, 11 sixth, and 144 seventh. So 23 is the element who is standing in front of the queue. So, and the 144 is the element that is at the rear of the queue. So if I want to add some new element in the queue, it will be added after 144, that is at the rear end. So insert element 200 in the queue at last. So 200 will be added in the queue at the last side, that's the rear side. If I want to delete something from the queue, you can see at the first location it was 23. So 23 will be deleted first because it is in the first location, that is first in, first out. The element that is first in the location with the first, the element that it can be have to be removed from the queue by first. This is how we can explain queue. Next is in linked list. In linked list, one is the linked list is a linear collection of data elements in which it is having two parts. One is the information part and other is the link part. So information part is data used in data structure, and link is the address of the next element. So first is the information that represent the data that we're going to use, and second is the link that represents the address of the next node. So linked list can be single linked list, double linked list, or circular linked list. Single linked list means in which the first element is having the link of next element. Double linked list means the element can have the address of next element as well as the address of previous element. That is double linked list. And circular linked means the last element of the linked list is again joined to the first element of the linked list. So this is what the single, double, and circular linked list is. So double linked list is, in double linked list, each element contains two pointers. One is pointed to the previous element and another pointed to the next element. Circular linked list in which last element is pointed to the first node of the linked list. Again, the various operations that we can perform on linked list are traversing, searching, insertion, and deletion. That we can access each element of the linked list at least once. Searching means to finding a particular element in the linked list. Insertion means that we can add the element in the linked list at any location. And deletion means that we can remove any element in the linked list again from any location. So traversing is processing each element of linked list at least once. Searching is finding the required element in the linked list. If the element is there in the linked list, we get the positive result. If the element is not there in the linked list, we get the negative result. Insertion means to add a new element in the linked list, either at the starting end or at the last end or in between, anywhere in the linked list. And removing linked list means that we want to remove an element. You can remove the element from front side, from last side, or in between any side, any location. So these are operations that we can perform on linked list. So you can see over here, root node. Root node means starting node. So you can see that it is having two parts. 8 is the, you can say, data. 24889 is the address of next element. So what the root node is, starting node. Starting node contains the address of the first node. So you can check over here. 8 is having address, particular address, then that is the 2348. And the 2489 is the address of next element. It will reach to next element. So 2489 means that A is linked to 59 because the address of 59 is 2489. So you can see 8 means the data that we are going to access, and 2489 means the address of next data that we are going to access. So here you can see 8 linked to 2489. 2489 means we visit over here at 59. The address of 59 is 2489. Again, the address linked to the 59 is 2648. So it means the element that is located at location 264 is 44. Then we access 44. That this is data. Again, link means we find that address 2647. We go to the address 2647. Again, we find the number is 8 over there. And next, there is no element over there. Next, there is no element. This become null. It means the linked list got end over here. So we have a starting point which mention the address of the first element, that is 8. 8 holds the address of next element. Next element is 59. 59 holds the address of next element. That next element is 44. 44 holds the address of next element, that is 8 again. And further 8 is linked to no other element. So there is no further joint. Between null means that linked list get end over here. This is how we can represent a linked list, that it has two parts. One part is the data, that is, you can say 8, and one is the address. Okay. So far we have done linear linked list, in which we have done array, stack, queue, and linked list. Now we start with the next one, that is the non-linear data structure. Every data item is attached to several other data items in non-linear data structures in such a way non-linear data structures, every data item is attached to several other data items in such a way that is specific for reflecting the relationship. So one item is attached to second item in such a way that represents either that item is the parent of the attached item, or that item is the child of that attached item, or that two items are sibling of some particular item. Fine. The data items are not arranged in sequential order. That is that they are not arranged one by one by one. They are in unordered way. That's why we call them as tree or graph. So various non-linear data structure elements are tree and graph. So we start with tree first. Tree is a non-linear data structure which organizes data in hierarchical order. Hierarchical means uh, one is the parent, next is the child, again that child is having further child, again that child is having further child. The data is stored in form of node and connected with edges of in a tree. So all the nodes in the tree are connected together with the help of edges. A tree with n vertices has exactly n minus one edges. If there's a tree having five nodes, then that five nodes are attached together with four edges. The first node from where the tree originates or starts is called the root node. So tree always start from the root node. So whenever we draw a tree, we always mention the first node as a root node. The node which has no more children or branches is called, the node which has one or more children or branches is called the parent node. If there's a particular node having further one node or more than one node, we call it as a parent node. A node which is a descendant of some other node is called child node. A node which have a particular parent, that node is called as a child node. The node belong to same parents are called sibling. If two nodes are having same parent, we call that two nodes as sibling. Degree of a node is the total number of children uh, of particular node is called degree of a node. If there's any particular node and that node is having, let's say, three children, then we call that the degree of that node is 3. So what is the degree of a tree then? The highest degree of a node among all the nodes in the tree is called degree of the tree. The node that is having the highest node, the degree, if we call that degree as a degree of a tree. Level of tree means each step from top to bottom is called level. The level count start with 0 and increment by 1 after each level. Height of a tree is total number of edges or lines that lies on longest path of the root from root node to the leaf node is called the height of the tree. We first start from the root and find out which is the last longest node of that tree and count number of edges. We call it as height of tree. Depth of tree, total number of edges that lies on the longest path from leaf nodes, depth of tree. And path is the sequence of node along the edges from one node to another node is called the path. So various operation that can perform on tree are, we can search an element in a tree, we can insert a particular node in a tree, or we can delete a particular node from a tree. Let's take this example. The first element, you can see I draw a tree over here. Root, I write the first element as root. It means this is the first element of the tree. The root is having further node 1, node 2, node 3. These three are the children of root. So root is having 3 children, degree of 3. So root is having degree 3, that is node 1, node 2, node 3. So You can also say that a root is a parent of node 1, node 2, node 3, because node 1, node 2, node 3, all these three having same parent, that is root. This means node 1, node 2, node 3 become sibling. If I talk about node 1 further having two nodes, that is node 4 and node 5, then node 1 will become parent of node 4 and node 5, and node 4 and node 5 are children of node 1, because node 4 and node 5 having same parent, that is node 1. This means node 4 and node 5 are sibling. Node 5 and node 6 are not sibling, because node 5 is having parent node 1, node 6 is having parent node 2. So both of these nodes having different parent, it means these node 5 and node 6 cannot be sibling. Sibling means the nodes that having same parent, node 4 is having parent node 1, node 5 having parent node 1, it means both having same parent, we call that node 4 and node 5 as sibling. Similarly, node 2 is parent of node 6 and node 7, node 3 is parent of node 8 and node, uh, you can mention, write some other name over here. So it means node 6 and node 7 are sibling. Now node 7 is parent of node 9 and node 10. It means node 9 and node 10 again are sibling. So what is the depth of node 9? You can see you start from node 9, go to root node. Start from node 9, go to root node, find number of edges. You can get first edge, that is node 9 to node 7. One edge is there, this is one edge. Node 7 to node 2, again there is one edge over here. Node 2 to root, again one edge is there. So there are three edges over here. Depth of node 9 is 3. Again, height of tree, we start from root. One path is root node 1, node 4. One path is root node 2, node 6. One path is root node 2, node 7, node 9. One path is root node 2, node 7, node 10. One path is root node 3 and node 8, and node 3 and node 3, let's say. Just find the longest path. Which is the longest path? So there are two longest paths, that is root node 2, node 7, node 9, or root node 2, node 7, or node 10. Both having same longest path. So you can choose anyone. You can choose anyone. Let's say we choose root node 2, node 7, node 9, and there are three edges over there. One edge from root node 9 to node 7, one from node 7 to node 2, one from node 2 root. So three edges are there. It means the height of tree is 3. Right? It means so whenever you have to count the height of tree, find the longest from root to child. So child, you can say node 9 or node 10, both are having same longest path if we start from root. So you can choose any one of it. Fine. So root is become level 0. Node 1 and node 2 and node 3, they are in one level. We call it as level 1. Node 4, node 5, node 6, node 7, node 8, and let's say node 3 is having level 2. And node 9 and node 10 are in one level. We call it as level 3. Fine. This is how we can represent. Let's say I tell you once again. This is node 1. Then these three become as level 1. Fine. And then all of these will become node level 2, and these will become level 3. Fine. So there are three levels over there. One is the level 0 root. One is level 1, that become node 1, node 2, node 3. One become level 2, that is the node 4, 5, 6, 7, 8, let's say 3. And then level 3 is node 9 and node 10. So in this way, we can find the node of the tree. Then graph. So if we talk about the graph, what is a graph? Then next nonlinear data structure is graph. A graph is a nonlinear data structure that we represent in a pictorial form as a set of objects where objects are connected by links. The interconnected objects are represented by points termed by vertices. So, and the link that connect the vertices are called edges. So we use the word nodes in case of tree. So we use the word instead of nodes, we use the word vertices. And in case of tree, we use the word edges. Similarly, we use the word same edges over here. So nodes are connected with the help of edges. So we always represent a graph with a graph name, but with vertices and edges. Vertex, each node of a graph is represented as vertex. Edge represent the path between two vertices or a line between two vertices. Path represents sequence of edges between the source vertex to destination vertex. If I start from one vertex and reach to other vertex, then I have to find a path. Then adjacent vertices, that two nodes or vertices are adjacent if they are connected to each other through an edge. So that are adjacent vertices. Operations where we can add a vertex, we can add an add, or we can display the vertex. So this is a graph. A, B, C, D, E are the vertices. A to B, B to C, A to C, B to D, C to E, D to E are the edges. So what is having 5 vertices? A, B, C, D, E, and 7 edges: A, B, B, C, C, E, D, C, E, C, C, A, and C, D. So 7 vertices are there. So this is how we can represent a graph. That a graph is a representation of vertices and edges. So how we can represent a graph. So the same matrix, we can draw a matrix. If there is any particular line between two vertices, we call that 1. If there's no edges between the two vertices, we call it 0. The same matrix is a 2D array, that is a matrix, two-dimensional matrix of V by V. Now that is number of vertices by number of vertex, where V is a number of vertices in a graph. In above example, the vertices are 5. So you can see there are 5 vertices over here. Then the two-dimensional matrix will be of 5 by 5. We declare 2D matrix as 5 rows and 5 columns. And a slot will become 1. We can say indicate 1 if there is an edge between two vertices, and we call it 0 if there is no edge between two vertices. So you can see 1 means A to B is 1. You can check A to B is a vertex over here, it become 1. Then B to C is 1. B to C is a vertex, you call it as 1. Right? And B to D is 1. B to D is 1. So you can write 1 if there's a vertex over there. If there's no vertex, let's say A to D, there's no vertex. So A to D, there is no vertex, so it becomes A to D as 0. Fine. In this pattern, you can draw a graph adjacency matrix. If there is a edge between two nodes, we call it as 1. We represent 1 in case of matrix or adjacency matrix, and it becomes 0 if there is no edge between two vertices. This is how we can represent the adjacency matrix if we draw a graph. Fine. This is all about the linear and non-linear data structures that we have just studied that there are four linear data structures, that is array, stack, queue, linked list, and two non-linear data structures, that is tree and graph. And we find that what are the various operations that are being performed in each of the data structures. Next is static and dynamic memory. As we told, used the word earlier. So what is memory allocation? Whenever okay. Again, whenever new node is created, memory is allotted by the system. This memory is taken from a list avail of those memory locations which are free or unused. Avail list holds vacant or unused memory locations. So we can utilize that unused memory location to the elements. Similarly, whenever new node is deleted, the deleted space become the space of that deleted element become free, and we put that empty space to the list of avail so that we can use that empty space future any use. Again, there are two types of memory allocation: static and dynamic. Static means when memory is allocated during compilation time, it is called static. The memory is fixed and cannot be increased or decreased. If more memory is allocated than required, then memory is wasted. If less memory is allocated than required, then program will not run successfully. So exact memory requirement must be known in case of static memory allocation. So static memory allocation means that we must know how much memory that program require during compilation. If we give the correct size of memory, the program will give us correct answer. If we give less space to the program will give us incorrect answer. If we give more memory to the program, definitely program will give the correct answer, but the memory get wasted. So you can see in static memory, there is a huge chance of wastage of memory or huge chance of unsuccessfulness of the program. To overcome this problem, we introduce the next concept, that is dynamic memory allocation, that we can change the size of memory, that we can increase or decrease as per requirement of the program. When memory is allocated during the runtime or execution time, it is called dynamic memory allocation. So when we allocate the memory during the execution time, we call it as dynamic. This memory is not fixed. We can change it as required by the program. This memory is not fixed and is allocated according to the program requirement. Thus, in this, there is no wastage of memory. So there's no need to know exact memory requirement in advance by the program. So you don't need to know how much memory the program require. Whenever we execute the program, whatever amount of memory required by the program, we allocate that memory. In this case, there is high rate of successful of the program, as well as there is least wastage of memory during the execution of the program. So this is all about the dynamic programming. And finally, last is the garbage collection. So what is a garbage collection is, the node is deleted, memory space become free, and immediately inserted into the free space that is available. I told you earlier, whenever we delete any particular element, that memory space become free. We collect that space, memory space, and put in the avail list. But this method may be time consuming for the operating system, because the deletion of element is very regularly. If we keep on if I did one element and the system will go to that particular memory space, collect that empty space and put in the avail. If we keep on doing all these things, the current running application will get disturbed. So to overcome this situation, we use the garbage collection. So what this garbage collection is? So another method is used in which is called garbage collection. Operating system collect free space in two steps. What steps are? In first step, the operating system goes through all the lists and tags all those cells which are currently being used. In second step, the operating system goes through all the list again and collect untagged space, that's empty space, and add this collected space to the availability list. So it find all the empty space together instead of finding the each and every space one by one. So it collect all the empty space together, and after collecting all the empty space, put in them the avail list. So the garbage collection may occur when small amount of free space is left in the system or no free space is being left in the system when CPU is idle and has time to do the garbage collection. Usually garbage collection is being done when the system is idle. So this is all about today's lecture. In fact, before closing the chapter, let me ask you one more question in your poll. Read it carefully, then give the answer of it.